Alrighty guys, this is your video notes for section 11.1. What we're going to be doing here is finding the area between two curves. So what you've seen previously is, at least when we were integrating, and think about it graphically for a second. Say you've got this random graph here. I don't know. We would typically find, say, the integral from 0 to 5. Say this function was g of x, right? Integral from 0 to 5 of g of x dx. That's this, right? And we would find that area to be fine. So it's very similar to this, except instead of finding the area of one curve, we're going to find the area between two curves, okay? And the general idea here is, look at this example graphically. You've got one curve f of x, right? And then the other curve g of x, okay? And so the way we would represent this is the integral from 2 to 4, that's just from 2 to 4, right? Where they intersect here, 2 to 4. They happen to have given this to us, but they don't always. We can find where they intersect. And then what we're going to do is we're going to take our top function, so f of x, that's up here, right? And subtract our g function area. And basically how that looks when you break it down, and the reason why it makes sense is because the area from 2 to 4 of f of x, 2 to 4 of f of x, right, is this, okay? And when we find the area from 2 to 4, again, 2 to 4 of g of x, that's this, right? And so what happens is when you subtract this piece out of f of x, what you'll be left with is what we're actually looking for here, okay? So the basic formula to take away is the area between two curves is going to be equal to the integral from a to b, so wherever they intersect, these two graphs, of f of x minus g of x, okay? Where f of x is typically your higher, top, bigger area, your bigger function has more area, okay? So let's take a look at example 1, right? It's asking us to find the area of the region bounded by this graph and this graph, and then these two lines, okay? So the first thing we need to do is sketch a graph and shade the region, but we don't have one given to us, so that's fine. All I'm going to do is make a quick table, which you really don't even need to do. There's not very many points, but we know x of 0 is right here, right? X is 0 here, and we know that x of 1 is right here. So again, it's not that much. So we're looking for something in between here. So I'm going to use 0 and 1 because it's such a small area. So if I plug 0 in for x, 0 squared plus 2 is 2. So that's 0, 2 right here, right? And then if I plug in 1, 1 squared plus 2 is 3. That's 1, 3 right there. Now, it's not going to be a straight line, and the reason why I know that, think about this, y equals x squared plus 2. This is a quadratic, right? A parabola that's been moved up by 2. So you should be able to draw it a little bit curved. But again, the picture doesn't have to be perfect. It's just to help you visualize some things. And then we don't really care about the other side, but you know it would come out and be symmetric. Something like that. Okay, so that's our first curve. And then we have our y minus equals negative x. Okay, so x and y. Here's our second curve. Again, I can plug 0 in. 0, I'll get 0. 0, 0. That's my first point. And then I can plug 1 in, and I'll get negative 1. 1, negative 1, that's right here. And again, this is a line with a slope of negative 1, so you should be able to draw that straight down. And again, we don't really care about what's past this dotted line here, but we may as well just continue just so we can see. All right, so shade the region. Well, I want the area between these two curves, right, and between these two lines. So that region is right here, right? And what you notice is your f of x function is always going to be your bigger one, right? The one that's on top. So this, I'm going to make my f of x function based on this formula here. So f of x happens to be this x squared plus 2. That makes my g of x this negative x, right? All right, so we are ready to integrate. So the area based on this formula here is going to be the integral from 0 to 1 of f of x minus g of x. So of x squared plus 2 minus negative x dx. And now notice I put this g of x in parentheses. Please please make a note to always, always do that, because again, with this negative, we need to make sure we take account for that distribution. Okay, so I'm going to simplify quickly. Negative and negative becomes plus x dx. Okay, and now I'm ready to integrate. And since this is a definite integral, we're going to be integrating and then applying the fundamental theorem of calculus. Okay, so let's do the integration first. Here we can integrate separately each of these. You can use the reverse power rule. Again, as a refresher, this is the reverse power rule, x of n plus 1 over n plus 1, right? So if our n is 2, that's 2 plus 1 is x cubed over 3, plus this becomes just 2x, plus this is to the first power, so x squared over 2. And then instead of writing the plus c, remember we're integrating from 0 to 1, okay? And that's where the fundamental theorem of calculus comes in, right? Because we need to evaluate f of b minus f of a, right? Okay, so the way we do that, f of 1, wherever we see a 1, we're plugging in to x. So 1 cubed over 3 plus 2 times 1 plus 1 squared over 2. That's my f of 1. Okay, and then minus my f of 0. Again, wherever I see an x, I'm plugging in 0. So this one's nice because it's all going to go away. Okay, we'll get 1/3 plus 2 plus 1/2 minus 0. And if you do all this simplification and common denominator business, what you will get is 17 over 6. Alrighty, there's your first example.